Okay, Math 2, we're going to look at graphing some radical functions, specifically the square root function. Now, the beginning of this is a review because we did parent functions earlier in the year. So, first I remind myself of the most important parts of my parent function, and I just can plug in some numbers. Now, I only plugged in numbers that gave me pretty answers. So, when I plugged in a 1, I got a 1. When I plugged in a 4, square root of 4 is 2, and the square root of 9 is 3. I plot those points, and I recognize that my square root function looks like this. Now it's easy to talk about domain and range. The domain are all my x values, so from here up, so it's anything greater than 0, and my range are my y values, and again it's only from y's up, 0 and up. Now we're going to start talking about undefined parts. Where is this function undefined? Well, it's undefined anytime you're less than 0, and I want to know why. Well, the y part is because it's because you can't have a negative inside your square root. You know, we don't like having that negative inside the square root. So anytime we have a negative inside our square root, we want to know when is that less than or 0? When is it negative? So that's going to be important for us later. A review of our transformations. We look over here. We know that A affects us whether we flip over the x-axis or not, if it's negative. We also recognize that if A is a number, it might vertically stretch or compress our graph. In other words, make it a lot taller or a lot shorter. Now the inside number moves the graph to the left and to the right, and the outside number moves it up and down. And of course that's a review. We did that several weeks ago. So let's take a minute and kind of look through what this one's telling us. Okay, first thing I notice is this graph right here. It's going to move to the right 2. That's going to move up 3. Okay, I took my parent graph, so that's just my parent graph, my normal graph, same one as up here, and then I did to the right 2 and up 3 for every single one of those points, and that's what it looks like. There are no roots because it never touches the x-axis. There is no y-intercept because it never touches the y-axis. It is undefined anytime I'm less than 0, and here's the important reason. Remember, I can't be negative. I can't take the square root of a negative. So why do I know it's undefined at less than 0? Well, I just take the inside of my radicand. X minus 2 is the inside of my radicand, and I know that that cannot be less than 0. So if I solve this little mini algebra 1 equation by adding 2 to both sides, I know that x cannot be less than 2. All right. Domain and range is a little bit older. Alright, so take a minute to kind of chew on that for a minute. We're going to do this next example, kind of the same idea. I started off, here's my parent function, so I'm just going to do that as a reference. On the inside, I moved left 3. The negative on the outside will reflect it over the x-axis, but the 2 is going to stretch it vertically. So I have to account for all of that. Okay. First thing it moves is, of course, it moves left because that's on the inside. So I move it to the left 3, and then I flip it, and then I stretch it by 2. Oh, that went way too fast. So I move it to the left 3, flip it, and stretch it by 2. That one doesn't move. The next one, I move to the left 3. 1, 2, 3. I flip it, which gets it down to here, and then I stretched it by 2, so it's 2 times bigger. So instead of going down 1, I went down 2. The next one, I move to the left 3, so I start here, I move it to the left 3, 1, 2, 3. I flip it, so instead of going over the axis by 2, I'm going to go down by 2. But it's really not down by 2, because remember, I'm going to do a stretch vertically. So instead of going down 2, I'm going to go down 4. And there's the point. I can do the same thing here. I move to the left 3. That puts me right here on the axis. When I flip it, it ends up being down here. And then when I stretch it vertically, it's twice as long as that, and it's here. There is a root at negative 3. The y-intercept is very hard to figure out. If you look real close right here, it's not a pretty answer, is it? But I know the y-intercept always happens when x equals 0. So if I plug in a 0 right there, which is right here, I can find the exact answer. 0 plus 3 is 3, So my answer is negative 2 square root 3. So even though I don't know it's an ugly answer, I know exactly what it is. It's negative 2 square root 3. All right. Again, why is it undefined? Remember, this part on the inside of the radical, x plus 3, cannot be negative. It cannot be less than 0. So if I solve this mini equation, I find out that x cannot, has to be, I know that when x is less than negative 3, it is. Some people forget that this right here means it can't be negative, and that's what we're talking about here. All right. Guys, there's some more to graph, but on the back side, I just want you to play around with those and see what you can do.